National Electrical Code Section 310.15b3 addresses ampacity derating for bundled conductors. This means that when multiple current-carrying conductors are grouped together, their ability to dissipate heat is reduced, and therefore their maximum allowable current, or ampacity, must be decreased. This requirement applies in various situations, including conductors bundled in conduit, conductors secured together with zip ties or other means, and conductors bunched together within a panel board or junction box. The purpose of derating is to prevent overheating of the conductors, which can lead to insulation damage, equipment failure, and potentially fire hazards. The amount of derating required depends on the number of current-carrying conductors bundled together. Note that the neutral conductor in a single-phase circuit, or the neutral conductor in a three-phase Y circuit where the majority of the load is nonlinear, count as current-carrying conductors. Grounding conductors and equipment grounding conductors do not count towards the total number of current-carrying conductors for derating purposes. If you have 3 or 4 current-carrying conductors bundled together, the ampacity of each conductor must be reduced to 80% of its value as listed in the appropriate ampacity table in the National Electrical Code, such as Table 310.16. If you have 5 to 9 current-carrying conductors bundled together, the ampacity of each conductor must be reduced to 70% of its value. If you have 10 or more current-carrying conductors bundled together, the ampacity of each conductor must be reduced to 50% of its value. To determine the allowable ampacity after derating, first find the conductor's ampacity from the appropriate table in the National Electrical Code, based on its size and insulation type. Then, multiply that ampacity by the derating factor that corresponds to the number of bundled conductors. For example, if you have 4 number 12 American wire gauge conductors with type THHN insulation bundled together, the ampacity of number 12 THHN is typically 30 amps, according to Table 310.16, but this depends on the temperature rating of the terminations at each end of the conductor and the ambient temperature. Since there are 4 conductors bundled, the derating factor is 80%, or 0.8. Therefore, the allowable ampacity after derating is 30 amps multiplied by 0.8, which equals 24 amps. In this case, you would need to protect the number 12 American wire gauge conductors with a 20 amp circuit breaker, because that is the next lower standard overcurrent protective device rating. It's important to remember that ampacity derating is cumulative. This means that if you have multiple factors that require derating, you must apply all of them. For example, if you have conductors bundled together and also exposed to high ambient temperatures, you must derate for both factors. The National Electrical Code provides correction factors for ampacity based on ambient temperature in Table 310.16. These correction factors are used to adjust the allowable ampacity of conductors when they are installed in areas with ambient temperatures higher than 30 degrees Celsius, which is equivalent to 86 degrees Fahrenheit. The ampacity correction factors are based on the insulation type of the conductor. For example, conductors with type THHN insulation have a higher temperature rating than conductors with type TW insulation, and therefore they have different ampacity correction factors. To determine the allowable ampacity after temperature correction, first find the conductor's ampacity from the appropriate table in the National Electrical Code, based on its size and insulation type. Then find the ampacity correction factor from Table 310.16 that corresponds to the conductor's insulation type and the ambient temperature. Multiply the conductor's ampacity by the correction factor to determine the allowable ampacity after temperature correction. For example, if you have a number 12 American wire gauge conductor with type THHN insulation installed in an area with an ambient temperature of 40 degrees Celsius, which is equivalent to 104 degrees Fahrenheit, the ampacity of number 12 American wire gauge THHN is typically 30 amps. The ampacity correction factor for type THHN insulation at 40 degrees Celsius is 0.88. Therefore, the allowable ampacity after temperature correction is 30 amps multiplied by 0.88, which equals 26.4 amps. In this case, you would need to protect the number 12 American wire gauge conductor with a 25 amp circuit breaker because that is the next lower standard overcurrent protective device rating. If you have multiple derating factors, such as bundling and ambient temperature, the derating factors are applied sequentially, not cumulatively. You begin with the initial ampacity of the conductor from table 310.16, then you multiply the initial ampacity by each derating factor, one at a time, to arrive at the final derated ampacity. The order in which you apply the derating factors does not matter, the final result will be the same. The National Electrical Code also contains exceptions to the ampacity derating requirements for bundled conductors in certain situations. For example, conductors that are installed in free air and are not subject to physical damage may not be required to be derated. Additionally, conductors that are used for control circuits or signal circuits may also be exempt from derating requirements. It is important to consult the specific requirements of the National Electrical Code to determine whether these exceptions apply to your particular installation. The National Electrical Code defines a current carrying conductor as a conductor that carries current under normal operating conditions. This includes ungrounded conductors, grounded conductors, and neutral conductors. Grounding conductors and equipment grounding conductors are not considered current carrying conductors, as they only carry current during a fault condition. The number of current carrying conductors in a raceway or cable assembly is used to determine the ampacity derating requirements. For example, if you have 3 current carrying conductors in a raceway, you must derate the ampacity of each conductor to 80% of its value. If you have 5 current carrying conductors in a raceway, you must derate the ampacity of each conductor to 70% of its value. The National Electrical Code provides tables that list the allowable ampacities of conductors based on their size, insulation type, and temperature rating. These tables are used to determine the initial ampacity of a conductor before any derating factors are applied. The ampacity of a conductor is the maximum amount of current that it can carry safely without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the size of the conductor, the insulation type, and the ambient temperature. Larger conductors have a higher ampacity than smaller conductors. Conductors with higher temperature ratings have a higher ampacity than conductors with lower temperature ratings. The ambient temperature is the temperature of the air surrounding the conductor. Higher ambient temperatures reduce the ampacity of a conductor. The National Electrical Code requires that conductors be protected from overcurrent. Overcurrent is any current that exceeds the ampacity of a conductor. Overcurrent can cause conductors to overheat, which can lead to insulation damage, equipment failure, and potentially fire hazards. Conductors are protected from overcurrent by overcurrent protection devices, such as circuit breakers and fuses. Circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a certain level. The size of the overcurrent protection device must be matched to the ampacity of the conductor that it is protecting. For example, a number 12 American wire gauge conductor with an ampacity of 20 amps must be protected by a 20 amp circuit breaker or fuse. The National Electrical Code also contains requirements for the installation of conductors. Conductors must be installed in a safe and workmanlike manner. Conductors must be supported and secured properly. Conductors must be protected from physical damage. Conductors must be installed in accordance with the manufacturer's instructions. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is important to consult the National Electrical Code before performing any electrical work. Failure to comply with the National Electrical Code can result in serious injury or death. In summary, National Electrical Code Section 310.15b3 mandates ampacity derating for bundled conductors to prevent overheating and potential fire hazards. The derating requirements depend on the number of current carrying conductors bundled together, with specific percentages outlined in the code. To determine the allowable ampacity after derating, use the appropriate tables in the National Electrical Code and apply the corresponding derating factor. Remember to consider additional factors such as ambient temperature, and consult the National Electrical Code for any exceptions or specific installation requirements. Understanding and adhering to these requirements is crucial for ensuring electrical safety and preventing potential hazards in electrical installations. Always consult the latest edition of the National Electrical Code and seek guidance from qualified electrical professionals for specific applications.